Okay, guys, this is our last video in the series for dosage calculation using dimensional analysis. And we're going to talk about dosage by weight. So the types of problems that we see with dosage by weight is going to be orders that are expressed as milligrams per kilogram or micrograms per kilogram or something like that. And then we also have what we call safe dosage type problems. And these problems are going to be where you're given an order from a doctor and you are asked to determine whether or not that order is considered to be safe for that patient. Okay, so the safe dosage problems are a little different than any of these other types of problems that we're doing. So we'll start with the dosage by weight, and we'll go through and discuss how to do those, and then we will come back and discuss the safe dosage type problems. Okay. All right. So let me stop this, and then we'll get started. Okay, so dosage by weight problems. The problem is going to give you an order that's expressed again as like milligrams per kilogram or micrograms per kilogram, something like that. Okay, so we're going to need that order, and we're also going to need the weight of the patient, and we're going to need what we have available. So in a lot of these problems up until now, we've needed the order and what we have available. So we're just adding another unit of measure to these problems, and that's going to be the weight of the patient. A lot of times the weight of the patient is given in pounds. So if it's given in pounds, you're going to have to convert that to kilograms. And as we have been doing in all of these problems, we're going to build that into the dimensional analysis problem and not work it out separately. Okay. So when you're reading these problems, don't forget to look at or read the entire problem to figure out what it is that you're looking for. What are you solving this problem for? Because sometimes it can be milligrams and sometimes it can be a volume measurement. So whether it's tablets or milliliters or whatever, okay? So we want to make sure that we are looking for um, or solving for the correct unit of measure when we're solving these, okay? And if the units of measure and dosing schedules don't match, then we want to make sure that we include a conversion. Okay, so this is just like all other problems. We'll read them and make sure that everything lines up. If it doesn't, we'll add a conversion. And remember again that these types of problems tell you what you need to plug in next. So don't get too bogged down in trying to figure out exactly what conversions you need. The problem will tell you what conversions you need. Okay. And again, don't calculate your kilograms separately and never round till the end of the problem. Okay, if you round before the end of the problem, you stand to get the problem wrong. And I'm going to show you what I mean on the next slide. Okay, so in this example here, you have an order for 40 milligrams per kilogram of a medication for a patient who weighs 59 pounds. So let's look at what happens if we solve it solving kilograms first and then rounding. So if we calculate kilograms, we take 59 pounds and convert that to kilograms. We get 26.8181818 kilograms. If we round that 26.8181818 to up, we're going to round it to 27 kilograms. If we then use that 27 kilograms and calculate our dosage, then we end up with 1,080 milligrams. Okay. However, if we calculate without rounding, so here you see 40 milligrams per kilogram times 26.8181818, we get 1,072.72 milligrams. Okay, so that's a pretty big difference. So we want to make sure that we are not rounding until the very end of the problem. Okay, so does that point or 8 point whatever milligrams really have an impact? Well, you don't really know that, and that's not for us to decide. So we want to make sure that we're providing the safest and most accurate care. So again, don't solve for kilograms separately. And always don't round until the end of the problem. Okay, if you absolutely have to convert your pounds to kilograms, which I strongly recommend that you don't do, but if you feel like you have to do that, then you need to keep that number exactly what shows up in your calculator. Okay, not round it. But that's not how we're going to solve them, right? Okay. All right, so let's work some of these problems out. Again, we're going to solve them the same way that we've solved all these other problems. We're just adding another element to the problem, and that's going to be kilograms. Okay. So this problem here, let's read it, and then we'll kind of dig it apart and solve it. So this a nurse is preparing to administer tobramycin 2.5 milligrams per kilogram IM stat to a preschooler who weighs 20 kilograms. Available tobramycin injection, 40 milligrams per milliliter. How many milliliters should the nurse administer for this stat dose? Round your answer to the nearest tenth. Okay, so step one is, what are we looking for? So we're going to look at our question, and it says, how many milliliters should the nurse administer for this stat dose? So we're looking for milliliters per dose. Okay. Step two is to build our box. And in our box goes our order. So don't forget, we need to indicate. So we kind of got away from that with IV infusions. We didn't need the day or dose indications, but don't forget, when we're solving any other problems other than those IV infusion problems, we're going to need to indicate whether this is a daily amount or a per dose amount. Okay, so this is going to be 2.5 milligrams per kilogram IM stat. So that's one dose, right? Okay, so this is going to look weird. It's going to look strange because we don't normally write fractions the way I'm about to write them. But remember, these aren't really technically fractions. Okay, so our order is for 2.5 milligrams per kilogram per dose. Okay, so we're going to write that as 2.5 milligrams over kilograms slash dose. Okay. I know it looks a little strange, but I promise you it's not. It's perfectly acceptable. Okay. All right. We also need the weight of the patient in order to solve these types of problems. And our patient weighs 20 kilograms. And we need what we have available. And what we have available is 40 milligrams per milliliter. So 40 milligrams over 1 milliliter. Okay, so now let's go or move on to step three, and that's going to be to plug into our problem, starting with what we're looking for. All right, so we've got milliliters right here. That's what we're looking for. So we need milliliters right here. So we come up and find milliliters in our box. It is, the milliliters is on the bottom, right? So we need to flip it. And let's see. So we're going to flip that and write that as 1 milliliter over 40 milligrams. And then cross it out. Okay. Now we're going to come down here, and our problem tells us what to do next, right? Milligrams here, so we need milligrams here. So we come up to our box and find milligrams. So 2.5 milligrams over kilograms per dose. And then cross it out. Okay. Now the problem's going to tell us what to put in next. Kilograms here. So we need kilograms here. So we come up to our problem or our box and find kilograms. So there's 20 kilograms. Cross it out. Okay, I've used everything in my box. So I'm going to cancel like units of measure and check and see what I'm left with and make sure it matches. I'm left with milliliters per dose, which matches what I'm looking for. So I can go ahead and do my math straight across. So 1 times 2.5 times 20 is 50. 40 times 1 is 40. 50 divided by 40 is 1.25. And the question or the problem asked us to round to the nearest tenth. So we're going to round that 1.25 to 1.3. And our units of measure, milliliters per dose. Okay, so you can see it's not too terrible. It's, again, we've added kilograms to the mix. This problem, we didn't have to convert pounds to kilograms. So sometimes you'll get lucky and they'll already have the kilograms converted for you, but sometimes we have to convert to kilograms. And again, we're going to build that into our problem. So let's look at a problem where we do have to do that conversion. Oops, sorry, I went too far there. Okay, so this question reads, nurse is preparing to administer furosemide 4 milligrams per kilogram per day, PO, every 12 hours to an infant who weighs 12 pounds. Available is furosemide oral solution, 10 milligrams per milliliter. How many milliliters should the nurse administer per dose? Round your answer to the nearest tenth. Okay, so step one, what are we looking for? Okay, we're looking for milliliters per dose. The question says, how many milliliters should the nurse administer per dose? So milliliters per dose. Okay, step two is to build our box. And in our box goes our order. And our order is furosemide, 4 milligrams per kilogram per day. So 4 milligrams over kilograms per day. Okay, again, I know it looks weird, but it's okay. Okay, we need the weight of the patient, which is 12 pounds. And we need what we have available, which is 10 milligrams per 1 milliliter. All right, so step three, now we can start filling in our problem. We're going to start with milliliters because that's what we're looking for. So we're going to come up to our box and find milliliters. Okay, milliliters is up there. It's just on the bottom. So we're going to change it and put it on the top. We're going to flip it. 1 milliliter over 10 milligrams. And then cross it out. Okay, now I have milligrams on the bottom. So the problem tells me I need milligrams on the top. So I come up here and find milligrams. So there's 4 milligrams over kilograms per day. And then cross it out. Okay. Now the problem says I have kilograms here, so I need kilograms here. So I come up to my box and look for kilograms. I don't have kilograms, I only have pounds. But that's okay because I know my conversion, right? 1 kilogram is equal to 2.2 pounds. Okay, so I'm going to plug that in. I'm going to actually plug it in just like that because I need the kilograms to be on top so that I can cancel kilograms out, right? So I'm going to say 1 kilogram over 2.2 pounds. Okay. Now, problem says you have pounds here, so you need pounds here. So I'm going to come up here and find my pounds, 12 pounds over 1 and cross it out. Okay, so I've used everything in my box. So let's cancel like units of measure and see where we're at. So we're going to cancel pounds, kilograms, and milligrams. Okay, if you skip this step and you solve this problem right now, you're going to get it wrong. Okay, why? Because I'm left with milliliters per day, and that does not match what I'm looking for. Okay, we can't forget to cancel out units of measure and see what we're left with. That'll help prevent us from making mistakes. This problem is not asking us to solve milliliters per day, it's asking us to solve for milliliters per dose. So we need to add one more conversion to the problem. So let's come up to the order. Remember, the order is what we're looking at. The doctor is telling us what to do. That's written in the order, and that's what we need to do. Okay, so the order says we're going to give this 4 milligrams per kilogram per day every 12 hours. Okay, so remember my cheat sheet from a couple of slideshows ago? Every 12 hours means 1 day over 2 doses. Okay, that means in one 24-hour period or 1 day, we're going to give 2 doses of this medication. So I'm going to plug that into my problem. I'm going to put the day on top because I want to cancel days out. 2 doses. Okay, see, now I can cancel out day. And now I'm left with milliliters per dose, which matches. So that means I'm good. Now I can solve my problem. So I'm just going to go straight across. 1 times 4 times 1 times 12 times 1, which is 48. And 10 times 1 times 2.2 times 1 times 2, which is 44. 48 divided by 44 is 1.09. And my rounding rule says round to the nearest tenth. So I'm going to round my answer to 1.1 milliliters per dose. Okay. All right. So remember, it looks a little weird how we're writing these orders, right? Because we have like a fraction within a fraction. Is kind of what it looks like. But again, remember, these aren't really technically fractions, so it's okay. We're going to solve them just like we solve any other problems. All right, so let's do another one. Okay, nurse is preparing to administer clindamycin, 10 milligrams per kilogram per day, PO divided into equal doses every 8 hours to a toddler who weighs 30 pounds. Available is clindamycin oral solution, 75 milligrams per 5 milliliters. How many milliliters should the nurse administer per dose? Round the answer to the nearest whole number. Okay, step 1, what are we looking for? The question says, how many milliliters should the nurse administer per dose? So we're looking for milliliters per dose. Okay, step 2 is to build our box. And in our box goes our order, which is right here, 10 milligrams per kilogram per day. So 10 milligrams over kilograms / day. Okay, we need the weight of the patient, which is 30 pounds. And we need what we have available, which is 75 milligrams per 5 milliliters. Okay, so now we're going to start plugging into our problem. We're moving on to step 3. Milliliters is what we're looking for, so we need milliliters right here. So come up to our box and find our milliliters. Okay, it needs to be flipped. Remember, we want that first one on top there. So 5 milliliters over 75 milligrams. And cross it out. Okay, now the problem says you have milligrams here, so you need to put milligrams here. So we come up here and find milligrams and plug it in. 10 milligrams over kilograms per day. And then cross it out. All right, now the problem says kilograms here, so I need kilograms here. Come out to my box. I have pounds. Remember, I told you this is going to happen a lot. Okay, because in the United States, we use pounds for our weight measurements. Okay, so 1 kilogram over 2.2 pounds. We're going to plug that in. Make sure your kilograms are on top so that you can cancel out your kilograms. Okay, now I have pounds on the bottom here, so I need pounds on the top here. So I come up to my box and find my 30 pounds. All right, I've used everything in my box. That's my indicator to cancel out and see where I'm at. Don't skip this step. I'm telling you, every time I say this, somebody's skipping a step somewhere. I don't know why, but it's just the way of the world. All right, so pounds is canceled out, kilograms is canceled out, milligrams is canceled out, and we're left with milliliters per day, which does not match what we're looking for. So that means we need to add one more conversion to our problem. Again, come back up to your order. The order is gospel. Okay, this medication is to be administered 10 milligrams per kilogram per day, divided into equal doses every 8 hours. Okay, so that means in one 24-hour period, we're going to give 3 doses. Okay, so if you give something every 8 hours, it's 1 day over 3 doses. Don't forget your cheat sheet. All right, so let's write it here, 1 day over 3 doses. I left the day on top because I want to cancel out days, and I have days on the bottom here, right? So I can cancel that out. And I'm left with milliliters per dose, which matches what I'm looking for. So now I can do my math straight across. 5 times 10 times 1 times 30 times 1, which is 1,500. And 75 times 1 times 2.2 times 1 times 3 is 495. 1,500 divided by 495 is 3.03. And it says round to the nearest whole number. So our answer is 3 milliliters per dose. Okay, getting the hang of it? I'm sure you guys are. All right, let's do another one. These are usually the ones that the students find a little more challenging. So we'll work a couple more and then we'll do some safe dosage problems. Okay, so this order or this problem reads, a nurse is preparing to administer amoxicillin 25 milligrams per kilogram per day, PO in equal doses every 8 hours to a preschooler who weighs 43 pounds. Available is amoxicillin suspension, 250 milligrams per 5 milliliters. How many milliliters should the nurse administer per dose? Excuse me, round the answer to the nearest tenth. Okay, step 1, what are we looking for? The question says, how many milliliters should the nurse administer per dose? So we're looking for milliliters per dose. Okay, step 2 is to build our box. Oops, let me just erase this. Okay, step 2 is to build our box, and in our box goes our order, which is right here, 25 milligrams per kilogram per day, 25 milligrams over kilograms / day. Okay, we need the weight of the patient, which is 43 pounds. And we need what we have available, which is 250 milligrams per 5 milliliters. All right, so now let's start plugging into our problem. As always, starting with what we're looking for. So we're looking for milliliters. We come up to our box, find our milliliters, right? We just need to flip it. We want those milliliters on top. So we're going to write that as 5 milliliters over 250 milligrams. Cross it out. Okay, now the problem says you have milligrams here, so you need milligrams here. So we come up to our box and find milligrams, 25 milligrams over kilograms per day. Cross it out. Okay, now the problem says I have kilograms here. I need kilograms here. Let's come up to our box. Surprise, surprise, we don't have kilograms. We only have pounds. but we know that 1 kilogram is equal to 2.2 pounds. So we're going to plug that in. 1 kilogram over 2.2 pounds. Okay, now we have pounds down here, so we need pounds here. So we can come up to our box and grab those pounds that we have there and plug that in and then cross it out. Okay, once we've used everything in our box, we're going to cancel all the like units of measure. Whoops, sorry. Let me undo. Okay, kilograms and milligrams. Okay, and I'm left with milliliters per day, which does not match what I'm looking for. So I'm going to come up to my problem here, and I'm going to look at what the doctor wants us to do. He wants us to give it in equal doses every 8 hours. So again, 1 day over 3 doses. So we're going to just plug that last conversion in, 1 day over 3 doses. Now we can cancel out that day, and we're left with milliliters per dose, which matches what we're looking for. So we can do our math straight across. 5 times 25 times 1 times 43 times 1 is 53.75. And 250 times 1 times 2.2 times 1 times 3 is 1650. 53.75 divided by 1650 is 3.25. And our rounding rule says round to the nearest tenth. So 3.25 is going to be rounded to 3.3 milliliters per dose. Running out of room here. Okay. Easy peasy, right? All right, let's do one more of these dosage by weight problems, and then we will move on and start some safe dosage problems. Okay. All right, so let's read the problem. Nurse is preparing to administer erythromycin 50 milligrams per kilogram per day, PO divided in equal doses every 6 hours to a toddler who weighs 32 pounds. Available is erythromycin suspension, 200 milligrams per 5 milliliters. How many milligrams will this child receive per dose? Round your answer to the nearest tenth. Okay, so there's something different about this problem, right? This problem says, how many milligrams will this child receive per dose? Okay, remember I told you sometimes they'll ask that, so make sure you're reading your problem thoroughly. So we're looking for milligrams per dose. That's step 1. Okay, step 2 is to build our box. So in this question, we don't need all the information that's provided in this problem. Okay, it's not asking us to calculate how much we're administering. So we don't need this volume. We don't need the dosage over volume amount. The only thing we need is the order and the weight of the child, and then any day overdose type conversions. Okay, so we're going to put in our box 50 milligrams per kilogram per day. We have the weight of the child, which is 32 pounds. Okay. And let's move on to step 3. I'm going to come back and show you what happens if you accidentally include this extra information, okay? So that you can see how the dimensional analysis problem can help guide you a little bit if you're trying to do it wrong, okay? So I'll show you that in just a second. All right, but let's go ahead and solve this the correct way. So step 3 is to start plugging into our problem, starting with what we're looking for. So we're looking for milligrams. So we're going to plug in milligrams first. 50 milligrams over kilograms per day. And cross it out. Okay, so I have kilograms on the bottom. I need kilograms on the top. So I come up to my problem or my box and I don't have kilograms, only have pounds. Not surprised, right? So we're going to plug in our conversion. 1 kilogram over 2.2 pounds. Okay, now the problem says, well, I have pounds here, so I need pounds here. So I come up here and grab my pounds out of the box. 32 pounds over 1. Okay, I've used everything in my box, so I'm going to cancel like units of measure. So pounds are gone and kilograms are gone. And I'm left with milligrams per day, which does not match what I'm looking for. I need milligrams per dose. So I'm going to come back up here and look at the problem. And it says this is to be divided in equal doses every 6 hours. Okay, so what's my conversion for that? 1 day over 4 doses, right? In one 24-hour period, this child is going to receive 4 doses of erythromycin. Okay, so I'm going to plug that in. 1 day over 4 doses. And then I can cancel day out. And I'm left with milligrams per dose, which is what I'm looking for. So I can now do my math straight across. 50 times 1 times 32 times 1 is 1,600. And then 1 times 2.2 times 1 times 4 is 8.8. 1,600 divided by 8.8 is 181.81. And my rounding rule says round to the nearest tenth. So my answer is 181.8 milligrams per dose. All right, so make sure when you're reading the problem, you identify what it is you're solving for. Don't just assume you're going to solve for milliliters. Okay, so now what I'm going to do is I'm going to show you what happens if you get this problem and you get confused and you think you need all of this information that's included. Okay, so I'm going to clear it. We're going to solve it again, but we're going to solve it incorrectly, or we're going to try to solve it incorrectly. Okay, so step 1 is milligrams per dose. So you're going to see the problem, it really tries to tell you when you're entering incorrect information. Okay, so let's pretend we decided we needed all this information. So 50 milligrams per kilogram per day, 32 pounds, and the 200 milligrams per 5 milliliters. Okay, so we've put all this stuff in our box. Now we go to step 3. And step 3 is to start plugging information in using, starting with what we're looking for. So we're looking for milligrams, so we would need milligrams here. So here's our first indicator that something's wrong. You have 2 choices up here. Okay, if you're setting this up correctly, you should not have 2 choices. Okay, that shouldn't happen. When you're putting your first piece of information into your problem, you should only have one of those pieces of information up here, or one of those units of measure. Okay, so that's your first indicator. So let's say you still don't know what to do. If you run into this problem, what you can do is you can say, okay, I know I need to use one of these 2 pieces of information. I either need to use this or I need to use this. So how do I determine which one? If you really can't figure it out, and the way I do it is I look at it and say, well, this didn't ask me for milliliters, so common sense says to me, I don't need this right here. It's not asking me for milliliters. But I understand that when you're taking these high stakes tests, it can get a little anxiety provoking and you may forget. So go ahead and start trying to solve the problem and see what happens. Okay, we just solved the problem using this 50 milligrams per kilogram per day, and we solved it just fine. But what if we started trying to solve it using the 200 milligrams per 5 milliliters. 200 milligrams per 5 milliliters. Okay, and then crossed it out. All right, now our rule says we have milliliters on the bottom, so we need milliliters on the top. Now you're going to run into a problem because you don't have milliliters up here. There's no milliliters, there's no liters. There's nothing that you can convert to milliliters up here, is there? There's nothing. There's no volume measurement up here at all. So that's basically the problem's second way of telling you, you're not doing this right, stop. Don't try to force it, okay? So what I would do is again, if you come across this situation, once you try to start solving it this way, you're not gonna be able to go past this step right here. It's just not. So go ahead and stop the problem and restart it, solving using the other information. And we just worked that out, and we worked it out using this measurement here and this here. We never even needed this right here. It's not necessary to solve this problem. So pay attention to what the problem is telling you. Follow your steps, follow your rules, and they will literally tell you exactly what to plug into the problem next. And if you don't have anything to plug in and there's no conversion available that you can plug in, then you're not doing something right. You need to stop, start over again, slow down, take a deep breath, and see if you can figure out what you're doing wrong. Okay? All right. That's one of the things that I really like about dimensional analysis is it does kind of guide you. You just have to have confidence in yourself and make sure you know all your steps. That's the key, really. Okay. All right. So the last type of problem that we're going to work on is safe dosage type problems. So safe dosage type problems are problems where you're given an order for an amount and the question asks if the order you received is safe. Okay, so basically it'll say the doctor ordered X amount of this medication, and then it's going to tell you that it's going to give you a recommended dosage. Okay, so it's going to say the doctor ordered this amount. The recommended dosage for this medication is this. Is this order safe? Okay, so we have to calculate using that recommended dosage. So this is a little weird because we're not going to use the order. Whatever the doctor gave us, that order amount, we're going to use that to compare, but we're not going to solve the problem using that amount. Okay, so you have to kind of remember when you see safe dosage problems that you're going to be using a little bit different information. So kind of gear your brain towards that. When you see safe dosage, you are solving for the recommended dosage amount. Okay, so it's going to give you a recommended dosage. Now it can be a range or it can be one number. If it's a range, you're going to have to calculate it twice, and we'll do one of each so that you can see. Okay. So once we calculate that recommended dosage, then we're going to compare. We're going to look at what the doctor ordered and we're going to compare it against what we just calculated. If it's a range, then the order should fall within that range. If it's one dose, the order should match it. Okay. But definitely shouldn't exceed it, and it shouldn't really be beneath it. It should match it. Okay, and the problems that you're going to be given, they're going to be ones that make it pretty clear that either match or they don't. Okay, and remember, finally, with safe dosage problems, you have to compare using the same units of measure and the same dosing schedule. You can't compare apples to carrots, right? You have to have apples to apples. So if the order is written in milligrams, then you need to solve for milligrams. If the order is written for milligrams per day, then you need to solve for milligrams per day. If it's written as milligrams per dose, you need to solve for milligrams per dose. Okay. All right, so let's look at these and walk through them step by step. Again, we're still using dimensional analysis. Okay. The big thing here is you have to wrap your brain around when you see, is this drug order safe? You need to know you are not going to be using the order. not to determine if it's safe, or you'll use it to determine if it's safe, but you're not going to use it to solve the problem. Okay, you're going to use it as a comparative. All right, so let's look at it and then we'll do it step by step. So this nurse receives an order for vancomycin, 300 milligrams IV Q6 hours for a patient who weighs 66 pounds. The recommended dosage for vancomycin is 40 milligrams per kilogram per day in 4 divided doses. Is this drug order safe? Okay, so there's a few things we have to look at here. First thing is, this is one of those problems that doesn't tell you, it doesn't explicitly say how many milligrams per dose. Okay, it's not asking you, or it's not kind of giving you that hint for what it is that you're solving for. So go back to my previous piece of advice. It needs to be apples to apples. So if your order is written as milligrams, then you need to solve for milligrams. Okay, because it has to match. We have to compare. So this order here is written as 300 milligrams. If I was going to write it in my problem, it would be 300 milligrams per dose, right? Because it says 300 milligrams IV Q6 hours. So that means every 6 hours, this patient's going to get 300 milligrams or 1 dose of this medication. Okay, so because that's the way the order is written, that's what I need to solve for. So I'm solving for milligrams per dose. Okay, again, in order to compare, and remember, that's the purpose of drug order or safe drug order type problems. We're comparing, and in order to compare, they have to be like items. So they have to be like units of measure, and it have to be like dosing schedules. So you'll go to the order, check the order and see how it's written, and that's what you're solving for. So in this case, it was milligrams per dose. Okay, so that was step 1. Step 2 is to build our box. In our box goes our recommended dosage, which is right here, 40 milligrams per kilograms per day, 40 milligrams over kilograms per day. And we need the weight of the patient, which is 66 pounds. Okay. All right, so now we can plug into our problem. And we're going to start with milligrams, which is what we're looking for. So we're going to plug in 40 milligrams over kilograms per day. Cross it out. Okay, problem says I have kilograms on the bottom, so I need kilograms on the top. When I look in my box, I don't have kilograms, I only have pounds. So 1 kilogram over 2.2 pounds is what I'm going to need to plug in next so that I can convert the pounds to kilograms. Okay, the problem says I have pounds on the bottom. I need pounds on the top. So I'm going to grab that 66 pounds. Okay, I've used everything in my box, so I'm going to cancel like units of measure. Don't skip this step. Pounds are canceled, kilograms are canceled. This is why we don't skip the step. We're left with milligrams per day. Does not match what we're looking for. We're looking for milligrams per dose. So we got to put one more conversion from our little day overdose cheat sheet. Okay, so let's look at the order. Remember, apples to apples. So we got to look at what the order says. And the order says Q6 hours. Okay, so Q6 hours means that in 1 day, this patient is going to get 4 doses, right? 1 24-hour period, 4 doses. So we're going to plug that in. 1 day over 4 doses. Okay, now we can cancel days, and we're left with milligrams per dose, which matches what we're looking for. So we can go ahead and do our math straight across. 40 times 1 times 66 times 1 is 2640. And then 1 times 2.2 times 1 times 4 is 8.8. And 2640 divided by 8.8 equals 300 in our units of measure, milligrams per dose. All right, so we're not done because the problem didn't ask us to calculate a dosage amount. It asked us to compare. It asked us if the order the doctor wrote is safe. So the order the doctor wrote right here, 300 milligrams per dose, right? So let's compare it to what we just solved for, 300 milligrams per dose. They are equal, which means that it is a safe dose. Okay, so remember when you're solving for safe dosage problems, your goal is to calculate the recommended dosage and then compare it to the order. Okay, calculate the recommended dosage and compare it to the order. All right, so let's look at another one. So remember I told you on the previous slide, I said sometimes it can be a range. So when it's a dosage range, you're still going to solve it the way we just solved it, but you're just going to solve it twice. Okay? So what do I mean by that? Well, let's look at this order and then I'll explain it. So the nurse receives an order for ampicillin 400 milligrams IM Q6 hours for a 10-year-old child who weighs 72 pounds. The recommended dosage range is 25 to 50 milligrams per kilogram per day in 4 divided doses. Is this drug order safe? All right, step 1, what are we looking for? This is a safe drug order question, so I know, because Ms. Hobbs told me, that we have to compare apples to apples. Okay, so the problem doesn't tell me what I'm solving for, but I know I have to compare the order against the dosage range. So I need to make sure that I'm solving for whatever the order is written in. So the order is written milligrams Q6 hours, or 400 milligrams per dose, right? That means every 6 hours, this patient is going to receive 400 milligrams of this medication, or 1 dose. So I'm solving for milligrams per dose. Okay, now, when I read the problem, I noticed it wasn't just a recommended dosage, it was a recommended dosage range. So that means they're giving me a minimum recommended dosage and a maximum recommended dosage. So the minimum recommended dosage is right here, 25 milligrams per kilogram per day. And the maximum recommended dosage is 50 milligrams per kilogram per day. Okay, so I'm gonna have to solve it twice using both of those numbers. So I'm gonna solve it the first time, solving for the minimum milligrams per day. And then I'm gonna solve it a second time, and I'm gonna solve it for maximum milligrams per day. Okay, because it's a dosage range, I have to solve both ways. So we'll start with minimum. Okay, remember we're solving for the recommended dosage. We're not using the order yet. So we're going to build our box, and in our box is going to go our recommended minimum dosage, which is 25 milligrams per kilogram per day. So 25 milligrams over kilograms per day. Okay, I need the weight of the patient, which is 72 pounds. All right. And then let's start plugging in. We know we're going to need other information, but the problem will tell us when we need that. So we're going to start plugging it in, starting with milligrams, because that's what we're looking for. So 25 milligrams over kilograms per day. Okay, the problem says now you have kilograms on the bottom, you need kilograms on the top. I come up to my box, I don't have kilograms, so I know I need my conversion because I only have pounds. So 1 kilogram over 2.2 pounds. So I'm going to plug that in. Okay, now the problem says I have pounds on the bottom, I need pounds on the top. So I'm going to plug in my 72 pounds from my box. Okay, now I've used everything in my box, so that means I need to cancel units of measure and see where I'm at. So I'm canceling kilograms and pounds, and I'm left with milligrams per day, which doesn't match what I'm looking for. I needed milligrams per dose. So I'm going to come up to my order here, and it says milligrams IM Q6 hours, Q6 hours, right? Q6 hours. So that means that in one day, we're going to give 4 doses. Okay, so we're going to add that to our problem. 1 day over 4 doses. And then cross it out. Now I can cancel day out, and I'm left with milligrams per dose, which matches what I'm looking for. So I can go ahead and do my math straight across. 25 times 1 times 72 times 1 is 1800. 1 times 2.2 times 1 times 4 is 8.8. 1800 divided by 8.8 is 204.54. And this is minimum milligrams per dose. Okay. Now we got to do it again. We got to do it using the maximum. So we're going to solve this entire problem all over again, but this time we're going to use 50 milligrams per kilogram per day. Everything else is the same. I am literally going to copy my box the second time. Okay, I just literally copied everything I used from the top problem, copied it because I'm going to use it. I'm going to solve this problem the exact same way. The only thing that changed is the maximum dosage changed, or the dosage amount changed from 25, which was minimum, to 50, which was maximum. Okay, so I'm going to plug it into my problem just like usual, starting with what I'm looking for, 50 milligrams over kilograms per day. Okay. Kilograms are on bottom, so I need kilograms on top. Okay, pounds are on bottom, so I need pounds on top. And then day on top, I'm literally copying what's above me. The only thing I changed was the 25 to 50. Okay. Right, so I still used all my information. I'm still going to cancel out and just make sure. Can never be too careful, right? So I'm left with milligrams per dose. Oops, that should be dose over here. Sorry about that. Okay, so I'm left with milligrams per dose. So now let's solve straight across. 50 times 1 times 72 times 1 is 3,600. 1 times 2.2 times 1 times 4 is 8.8. 3,600 divided by 8.8 is 409.09. And this is maximum milligrams per dose. Okay. All right. So we're not done. All we've done is solved the recommended dosage range for this child who weighs 72 pounds. So we've determined that the recommended dosage, minimum dosage for a child that weighs 72 pounds is 204.54 milligrams per dose. And the recommended maximum dose for a child who weighs 72 pounds is 409.09 milligrams per dose. But the question didn't ask us that. It asked us if that 400 milligrams per dose order that the doctor wrote was safe. So what you need to do is you need to create a little number line. This will help because a lot of times students get a little confused and they say, well, this is 409, so that means it's too high and it's not safe. Okay, so this will help prevent that. Draw a number line. Okay, on one side of the number line, draw your minimum dosage, which was 204.54. And on the other side of your number line, put your max dose, which is 409.09. And then you're going to take what the doctor ordered and you're going to plot it. So where does it fit in this? Is it less than 204.54? Is it more than 409.09? It's not. It falls probably right about here, right? 400. Okay, so as long as it falls in between these two lines or these two numbers, it's a safe dosage. Okay, so all of that work and your answer is yes, this is a safe drug order. Okay, so yes, it's a little bit of work. It's a little bit of extra steps. If you're competent in math and you're comfortable with math and all of that, you may have noticed that you could simply double this amount to come up with this amount because the minimum dosage range was 25 and the maximum was double that, 50. Okay, but you're going to solve it however you're comfortable solving it, and I'm okay with that. If you're not comfortable with math, if you're not feeling really comfortable, then I suggest you just solve it twice. And that's what I do. Okay, just because I want to be safe, I just go ahead and solve it twice. Okay. All right, so that's it for safe dosage and dosage by weight. So we're going to end this video and let you guys start working on some of these types of problems. And of course, all these videos are available to you, so you can rewatch them if you need to. And just work these problems, repetition, repetition, repetition. Okay, guys? So y'all take care and have a good evening.